Good morning, friends. Mrs. McBride here. Hopefully everybody had a wonderful weekend and you had a chance to get out and enjoy some sunshine. Here's your joke of the day. Why did the ruler have a bad report card? His grades just didn't measure up. All right. Our goal for today is to finish this right-hand side of page 6. So we've got two practice problems. This one is just sort of to get your head in the game, and this one is pretty tough, so we'll see if you can do it. This one says a 4 times 10 to the negative 7 kilogram styrofoam bead has 600 excess electrons on its surface. What is the magnitude and direction of the electric field that will suspend the bead in midair? Okay, so first thing we have to say to ourselves is, if it's suspended in midair, I know you're excited about this, but let's draw a free body diagram. Okay, so if we do this, we're saying what forces are acting on the object. My cat is totally trying to get in this video. We'll hope that he doesn't. Kiwi, thank you. All right, so what forces are acting? Well, we've got the force of gravity going down, and there must be something pulling this up if it's suspended in midair. Okay, and this force is actually the electrical force. Now they're trying to trick you because you might think to yourself, aha, I know this is KQ1 Q2 over R squared, but we don't have two forces acting here. Okay, so what we would use here is the electric field. Okay, so if we know E equals FE over Q, we could solve for FE, this is one of my favorites, which gives you EQ, or eek. Okay, so we're basically saying that FE has to equal FG, or in this case we could say eek equals mg. Okay, now we're looking for the magnitude and direction of the electric field, so let's go ahead and plug in our numbers for the rest. Now what's the charge acting here? Again, I'm trying to be a little tricky because I didn't quite give you the charge, but I gave you that we have 600 excess electrons. So hopefully you're saying, well, we need to do 600 times the charge of one electron equals mg. Now the mass for e to the negative 7, and everybody's favorite, let's use little g as 10 just to make those 9.8ers mad. Okay? All right, take a second here and let's solve this. So we're basically doing 4e to the negative 7 times 10 divided by this. Don't forget to use good parentheses here. Okay, hopefully you got the same answer as I got. It looks like 4.17 times 10 to the 10. Oh, that's a pretty big field, okay? 4.17 e to the 10 newtons per coulomb. Okay, hopefully you're warmed up. Here we go. This next one is a little bit more tricky. This one says a charged ball of mass 0.01 kilograms and a charge of negative 6 microcoulombs. Remember, this micro is e to the negative 6, right? Is suspended between two metal plates with an electric field of 3,000 newtons per coulomb. I have two questions here. What angle does the ball hang, and what is the tension in the string? Okay, so we're going to do the same sort of thing we did before, where we're going to write down what's happening here. Okay, so what forces are acting? Well, let's start with everybody's favorite, the force of gravity. Okay, and to me it looks like something is pulling this to the right. Okay, what do you think is pulling this to the right? Hopefully you're saying to yourselves, aha, this is being pulled to the right by the electric force, okay? Which again, we're gonna use as eek because it gives us the electric field, okay? And now there's two components of forces here, okay? So if this is theta, this right here, the vertical component, is the opposite side, or excuse me, is the adjacent side. So since this is the adjacent side, we know that adjacent goes with cosine, or this side is t cosine theta. This side over here is the opposite side of the angle, and since it's the opposite side, we go t sine theta, okay? And if it's just hanging there, I hope you're saying to yourself, look at this. We can set up two sets of equations, okay? So let's set up these two first, which says that t sine theta is equal to eq. And then the other one, we could say that t cosine theta is equal to mg. Okay, now this is good. Now what we're looking for is what angle this hangs at and what the tension in the string is. And this is good news here, friends, because we've got two equations with two unknowns. All right, so what I'm going to do is I'm going to solve this equation for t. So how do I get t by itself? Okay, I get t by itself by dividing both sides by cosine theta. So I'm going to solve this equation to get t equals mg divided by cosine theta. And then I'm going to take and I'm going to substitute this in to this equation. So I get over here mg over cosine theta times sine theta equals eq. All right, hopefully you're on your game and you're saying to yourself, aha, Mrs. McBride, sine theta over cosine theta is equal to? I hope you're all out there saying tangent theta. Your pre-calc teachers would be very happy if you said those, okay? Now, what am I solving for? What am I doing with this here? Okay, I am doing with this, I need to find what is the angle and what is the tension. So over here, I can find the angle. But first, let's do a little math. I'm going to divide both sides by mg. So I get tan theta equals EQ over mg. Okay. What's E? E is my 3,000 newtons per coulomb. And my Q is -6 e to the -6. Remember, that's the micro up here, right? And I'm going to divide this by the mass, which is 0.01 times g, which is 10. Okay, so I'm going to find an answer for that. All right, so I've got 3,000 times -6 e to the -6. I'm going to divide this by parentheses, 0.01 times 10. Okay, so I get that. I'm going over here. So I get that the tan of theta is equal to -0.18. I can solve for theta by taking the inverse tangent of -0.18. And for me, I get an answer of, oops, sorry. That theta is equal to -10.2 degrees. Okay, we're halfway there. Which just means that once we have this theta, we can go back in and solve for the tension. Okay, so again, tension equals the mass, which is our 0.01, times little g, which is 10, divided by the cosine of -10.2. Okay, so here we go. 0.01 times 10 divided by parentheses, cosine of negative 10.2. Double parentheses there. Okay, and the exciting answer is that the tension is equal to, I got 0.1 newtons. All right, friends, that's all she wrote for today. Have a wonderful day.